Okay, now we're going to have a look at sketching these things. So if I have 9A, they just want me to sketch the normal graph, and this is 9 for both courses, by the way. If I have 9A, they want me to sketch the normal graph of y equals the absolute value of x. Now, this means y equals positive x or y equals negative x. And this is kind of one of the reasons that I got people to do these previous questions this way, because it helps out with the maths for this, even though it wasn't as easy as another way to do it, if that makes sense. Anyway, now, this means y equals positive x or y equals negative x. You may be like, but which one is it? It's both, but in different places. So, if I just have a look at the graph of y equals positive x first, well, its y-intercept is 0, and it goes up with a gradient of 1. So it's going to keep going up like that and going down like that. But absolute value functions are never negative. Well, the base one isn't. So it reflects like that. Like it reflects back when it's negative. So for x is greater than 0, y equals positive x. X is less than 0, y equals negative x. And x equals 0, well, it's a 0 anyway. Okay, so that's the basic one. So now if we're talking about moving it upwards, well, instead of being like that, it's going to be like that. If you're talking about it moving left or right, it's going to be like that or like that. And then, of course, you could get things going like that. But let's have a look at some of these actually happening in 9B. So for number 1. Oh, before we go into 9B, I'd like to remind you, if I've got f of x take h plus k, it's moved right h and up k. Okay? Math teacher humour. So if I have y equals the absolute value of x take 3, the take 3 is h, because it's in the absolute value with it. It's not just tagged along and afterwards, which means we've moved right 3. So if we have our normal axes, y, x, normally we would have been like that, but this time we've been moved right 3. And these don't necessarily stop there. They would have kept going, I just didn't have room. Let me draw that nicer. That's it. So this one turns about at x equals 0. This one turns about at x equals positive 3. Did they want intercepts? No, they just wanted the equations of the two branches. So we've sketched it. Equations of two branches of the two branches. Well, we have positive x take 3, y equals positive x take 3, and y equals negative x take 3, which means for y equals x take 3, because it's a positive out the front, y equals negative x plus 3, which is the same as y equals 3 take x. So the y equals x take 3, that's this one, yeah? So when x is greater than or equal to 3. The other one is this sad looking downward one, because it's got a negative gradient. When x is less than 3. Okay, let's have a look at Oh, I'm not going to do II just because it's really similar to I, but it's moved left to. I'm going to do III. So for III, we have the y equals the absolute value of x, take 2. So which means it hasn't moved left or right because there's nothing in the absolute value with the x. It's moved down 2. Okay, so that's because the minus 2 came after it, like k does. So this means that if we have our nicer looking axis, y and x, instead of having a graph that goes up like this, well, it's been moved down 2 spots. It's been moved down 2 spots, and we don't just stop there. We go as long as our ruler can let us. Which rules? The equations. Well, oh, and this turned around. This one was y equals 0. This one's at x equals 0, y equals negative 2 because it's gone down 2 spots. So for the equations, we've got y equals positive x, take 2, and y equals negative x, take 2. So the take 2 was afterwards, so we don't need to change its sign. It's just for the x. Okay, and now I'm going to have a go at this question. So absolute value of x, take 2, take 1. So that's question 5. So y equals the absolute value of x, take 2, take 1. So this is moved right 2, down 1. So it's moved down 1, and it's moved right 2. So if I do my, oh my gosh, I can make a joke out of a game out of how many times I say so, or hello, y, x, what was that? X, thank you. So, or out of thank you, and what was that? Okay, so instead of, oh, that was a bit dud. There we go. Instead of looking like that, we've moved right 2 and down 1, 1, 2, down, 1, 2, and down. And then we just use our ruler to keep going. So this one turns around at x equals 2, y equals minus 1, as you'll notice. Okay, so the equations, we've got y equals positive x, take 2, take 1, or y equals negative x, take 2, take 1. So y equals positive x, take 2, take 1 is y equals x, take 2, take 1, which is y equals x, take 3. And this other one, y equals negative x plus 2, take 1, because minus minus, y equals negative x plus 1, which is the same as y equals 1, take x. They are the same. And that's question 9.